Hey everyone. Today we are going to redefine sine and cosine and tangent so that we can use them for any angles, not just ones that are stuck inside a right triangle. This is going to be an important first step towards figuring out why the sine and cosine and tangent graphs look the way they do. Let's get started. We need to first set up a little groundwork before we can go too far. So for any point, xy, on the plane, it's helpful to sometimes think about the distance that that point is away from the origin, which is what we call its radius, as well as its angle, which would be the angle of a ray that runs through it. So let me pull out two rays a moment. We've got an initial ray and a terminal ray. And let's rotate our terminal ray around towards this angle. All right, enough kidding around. So if we have a point, xy, and this distance away from the origin, they're related by way of the Pythagorean theorem. And so anytime you know the coordinates of a point, you can calculate this radius by simply solving with x squared plus y squared equals r squared. Now, assuming we can get our hands on a couple of numbers, an x, a y, an r, and a theta, we can redefine the major trig functions like this. We redefined sine not as opposite over hypotenuse, but as the ratio between the y and the radius. And we defined cosine no longer as adjacent over hypotenuse, but as x over the radius. And tangent is y over x. You can memorize them as such, and it's probably important that you do that, but I would hope long term that you might think of sine, since it's related to the y, as kind of a height of sorts, that you would start to think of cosines being connected with that x as a width, and that you would think of tangents being connected to both y and x as kind of like slopes. In fact, slope is change in y over change in x, and so I don't think that's too much of a stretch to think about. So here's an example that might bring this into play. I've got an angle drawn in here, and I want to measure how big the angle is, and I want to pick some point on this and measure its x and y coordinates. So let me pull out a measuring stick a second. And if I rotate this around, I can see that this angle's close to 170 degrees. And let's pick a point on this a moment and measure, first of all, what its radius is. So its radius is about 12.5 or so. And if I measure its width, that's about 12 centimeters. And if I measure its height, that's roughly 2.5, 3, somewhere in there. So let's label all those a moment. We've got our angle measured as 170. We've got our x coordinate is 12 centimeters. Now something that's extremely important when we're looking at these trig functions is because we had to go backwards in the normal xy plane. We had to go backwards 12 units. X really needs to be written as a negative 12 centimeters. Our height was about 2. That's a normal positive height, and so I'll leave that as 2. And then our radius was somewhere around 12.5. Another important aspect here, radiuses will always be positive no matter where you're pointing. And so if I have all those different things like that, now I can calculate what sine of 170 is. Sine of 170 would be the y coordinate divided by the radius, or it's going to be approximately 2 divided by 12.5. And 2 divided by 12.5, if we type that into our calculator, is about 0.16. And if we wanted to know what the cosine of an angle is, we could take its x coordinate and divide it by its radius. And so that would be negative 12 divided by 12.5. And again, on a calculator, negative 12 divided by 12.5 is negative 0.96. If we wanted to know what its tangent is, we would find its slope. And so slope would be 2 over negative 12. Rise over run, right? 2 divided by negative 12. And 2 divided by negative 12 is approximately negative 0.16. And that works, but it's really slow to calculate it this way. Thankfully, our calculators have sines and cosines and tangents programmed into them. And so the true value for 170 degrees, if I were to type sine of 170, it gives me 0.17. Notice that 0.17 is pretty close to the 0.16 that we had measured with our estimates earlier. But our calculator is more precise, and so we usually go with our calculator's version. If we typed in cosine of 170, I would expect a number close to negative 0.96. I got negative 0.98, which is really close. And if we type tangent of 170, I would expect a number close to this negative 1.6. Let's see how we did. Negative 0.17, not bad at all. Now, if you need a sine or cosine or tangent value for some angle, please use your calculator. But I want you to realize that the numbers that the calculator gives you are not just some sort of black magic. It is based on these sort of definitions. It's just that it's more precise than we are when we measure it by hand. Here's a chance for you to try it. So I have an angle drawn in here. Why don't you try to estimate its angle? Looks like it's more than 270, less than 360. I found some point on it, and so see if you can estimate a radius and go through, find sine and cosine and tangent. If you want to hit pause a second, you can do that. When I did it earlier, I estimated an angle of about 300 degrees, and I estimated a radius of about 7. Which isn't exactly right. You could get a little bit better answer if you did 3 squared plus 6 squared, but my estimates were pretty close to the true values over here. Here's another one that you could try. Again, hit pause if you'd like. When I did this one earlier, I estimated that it was about 205 degrees, and the radius I calculated using the Pythagorean theorem and rounded a little bit to be 7.5. And so here are the values that I got. Now, something that's really important to catch is that sometimes sines and cosines and tangent values come out to be positive, and sometimes they come out to be negative. And that really depends on what quadrant the angle you're working with is in. And so let's think a moment about each of those and see if we can learn when sines are positive and negative, and when cosines are positive and negative, and so forth. So when we're thinking sines, remember I want you to kind of think about heights. And so the heights are going to be positive in quadrants 1 and 2 because you're above the y-axis, and they're going to be negative in quadrants 3 and 4 because you're below the y-axis. When we think about cosines, I want you to kind of think of them as widths of sorts. And so they're going to be positive in quadrants 1 and 4 because you're to the right of the x-axis. And they're going to be negative in quadrants 3 and 4 because you're to the left of the y-axis. And finally, let's think about tangents. Remember, I want you to think of tangents as slopes because they are change in y over change in x. And so if we have a ray that's going through quadrant 1 here, that's going to have a positive slope. And if we have a ray here in quadrant 3, that's also going to have a positive slope. It's a little weird to think about, but the y is negative as well as the x is negative. And when you divide a negative by a negative, you get a positive. Then when you're in quadrant 2, any rays that we have here will be negative, as well as in quadrant 4. Why don't we organize this in a little bit of a table a moment? So we've got sines. Eventually we're going to figure out what sine of 0 and 90 and 180 are. But for now, we know that sines are positive in quadrant 1 and negative in quadrant 2. Sorry. Let's see if we can organize our work into a table. We know that sines are positive in quadrant 1 and positive in quadrant 2. And then they are negative in quadrant 3 and negative in quadrant 4. We know that cosines start off positive, and then they're negative in quadrant 2 because you had to go to the left. They're still negative in quadrant 3 because you're still to the left. And then they become positive again in quadrant 4. When we look at our tangents, tangents start off positive in quadrant 1, then they go negative in quadrant 2, then they're positive again in quadrant 3, and negative again in quadrant 4. They alternate. Now, here's a popular type of question that you will probably see. It asks you to evaluate all 6 trig functions for an angle that goes through the point negative 5, 12. And so we have been told an x-coordinate and a y-coordinate. Why don't we take a moment and see if we can figure out what the radius would be here. And so if we were to put in negative 5 squared and put in a 12 squared and calculate this, negative 5 times negative 5 becomes positive 25. And 12 squared is positive 144. Notice how each of those, even though one of them started out negative, ended up being positive. This is why the radius always is a positive number. 25 plus 144 is 169. And 169 happens to have a nice perfect square root. And so the radius for this particular problem would be exactly 13. Now that we know what x and y and r are, we can define sine, cosine, and tangent based on our definitions. And so let me pull out a table here to organize our work a moment. So sine is going to be the y-coordinate over the radius. And so that will be, the y-coordinate was 12, and the radius was 13. And so we would say sine of theta is 12/13. Cosine is going to be opposite. Cosine is going to be the x-coordinate over the radius because it's a width. That's a negative 5 for x and a 13 for the radius. And then tangents are like slopes, and so they are y's over x's. And so that would be a 12 over a negative 5. You can leave the negative sign in the bottom. A lot of times people will put it on top or even out in front, but tangent of theta is negative 12/5. Then there are 3 other trig functions, and those 3 others are the reciprocal trig functions. So sine's reciprocal is cosecant, cosine's reciprocal is secant, and tangent's reciprocal is cotangent. And it's probably best that you memorize them that way, as reciprocals of things, as opposed to r over y or some combination of letters like this. And so if we wanted to complete our table, cosecant is the reciprocal of sine. And so it's going to be the reciprocal of 12 over 13. And so that would be 13 over 12. And secant is the reciprocal of cosine. And so that's going to be 13 over negative 5. Oops. And cotangent is the reciprocal of tangent. And so we can do negative 5 over 12. Let's look at another example. This time I want to find the 6 trig functions for specifically the angle 270 degrees, which goes through the point -3, 0. That's actually a typo. It doesn't go through the point -3, 0. 270 would be down, and so it would have a x-coordinate of 0 and a y-coordinate of -3. Got that backwards. Like last time, why don't we find a radius real quick? And so we can do that by putting a 0 in for x and a -3 in for y and calculating what we get here. So 0 squared is just 0, and -3 squared is +9. And so when we add those together, we get a 9. And 9 has a nice square root. That's exactly 3. And so our radius in this case is going to be 3. So if we pull out a table, sine, cosine, tangent, and so forth, we can calculate all of those. We've got sine of theta is the y-coordinate divided by the radius. And so that would be -3, the y, divided by the radius 3. -3 divided by 3 is actually a nice number. It's exactly -1. And you might notice that if you take your calculator and type sine of 270, instead of coming out to be some weird decimal like they usually do, you get an exactly -1. Cosine of theta is its x-coordinate divided by r. And so cosine of 270 would be 0 divided by 3. And 0 divided by 3, like 0 divided by anything, is exactly 0. Tangent is kind of an interesting one. Tangent is the y-coordinate divided by the x-coordinate, and so that would be -3 divided by 0. Now, I think you've probably heard before that you can't divide something by 0, and so -3 divided by 0 is undefined. And I think that actually makes a little bit of sense to me when you think about tangents as slopes and you think about 270 degrees. 270 degrees, the ray is exactly up and down. And I hope that your algebra teacher has taught you that slopes of vertical lines are undefined. When we try to reciprocate each of these, the reciprocal of -1 is still -1. And so cosecant of 270 would be -1. The reciprocal of 0, remember this was originally 0 divided by -3. When we try to reciprocate that, now we have -3 divided by 0, and so that is undefined. And then cotangent, if we try to reciprocate -3 over 0, we're back to 0 over -3, and that would be 0. So kind of interesting sine, cosine, tangent of 90 and 180 and 270 and 360 all have relatively nice answers like -1s and 0s or undefined. So if we go back to this chart from earlier, we saw that sine of 270 is -1. We saw that cosine of 270 is 0. And we saw that the tangent of 270 is undefined. I would encourage you to take a moment and hit pause and see if you can find sine, cosine, and tangent for 0 and 90 and 180 and 360 and complete this chart. If you don't want to take the time to do that, I'll fill it out right now too. Hopefully you were able to fill out some of these other values. This chart is going to become a lot more important to us in our next lesson when we start looking at the graph, and so we'll revisit it there for sure. Let me know if you have any questions about how sine, cosine, and tangent are now defined as ratios of x and y and r, and I'll catch you in the next lesson.